Good morning, everyone. Thanks for being here. This is the second podcast we are organizing in Kit for SME project about standardization. Today, we are here to speak about standardization in the circular economy sector. This podcast will be promoted through AI for Manufacturing channels, so you will have the opportunity to listen to it. And this is the second podcast we are organizing. The podcast will see an introduction about the standardization events we are organizing. Then the projects are joining today will present themselves, and we will speak about standardization and the standards that are used among these different projects, highlighting the pro and cons and speaking about procedures and methods that maybe could also be improved and on which we could work on. Moreover, the goal of today and in general of these events is to discuss about standardization, exchanging knowledge and experience, and promoting the usage of standards among different projects. Holonix is organizing these online events because Holonix is the task leader in Kit for FME project about standardization. At the moment, we have organized a first podcast that was about standardization in the manufacturing sector that are adopting artificial intelligence. Today, we will speak about standardization in the circular economy sector, and we will have the final podcast about standardization and data management. About 8 different projects have been involved since today in these 2 podcasts. So we are sharing quite well this topic among the projects. What is the standardization? According to the international organization, a standard is something like a document established by a consensus of subject matter experts and approved by a recognized body. The objective of the standardization is to provide guidelines on the design, on the use or performance of material, products, processes. So the idea is to have a common and repeated uses of rules, guidelines, of a way to make some activities in order that also different actors could act and work together in a same recognized way. The standardization is like the last step, starting from the research, industrial support, and then we have the standardization in order to reach the innovation, because research gives methodology and some functionalities. The industrial support gives value in order to bring it to the market, and then thanks to the standardization we achieve the stability and the security for investing. In general, the main benefits that we have when we adopt standards are technologies that can work smoothly and in a reliable together. Then we could provide economies of scale, foster research and innovation, and thanks to standards, we keep the markets open. Now, today we will be here with 3 European projects, Kit for SME, C4Con, and XMANAI. I'm going to present Kit for SME project. That is a project that started in October 2020 and will end in few months, in March 2024. 8 million funding received from the Horizon 2020. 2.5 million were dedicated through our project to fund actions with 2 rounds of open calls. And more than 18 partners have been involved in this project, coming from 8 different countries in Europe. And in our consortium, we have 4 digital innovation hubs that help to widespread reaching the platform, and 4 internal pilots. All pilots coming from manufacturing sector, using artificial intelligence, and also trying to adopt some artificial intelligence technology in order to make some circular economy. This is the map about our consortium. And in general, let's say that Kit for SME was born from a survey among companies in the manufacturing fields that were testing artificial intelligence technologies. And this survey asked about the usage of artificial intelligence in 5 different topics inside a company: the digital and smart factory, data strategy, human resources, organizational structure, and organization culture. And the answer from this survey was that about 40 companies were interviewed, and nearly half of them were not using any kind of artificial intelligence solution. For this reason, these make the upcoming of the Kit for SME platform, where leveraging on the network of the Digital Innovation Hub, the idea was to create a platform to push it to its limit by offering to external actors, through, for example, also open call, a marketplace where the companies could ask for specific services using artificial intelligence. The Kit for SME project targets European SME and mid-caps, and try to give them some scope, tailor and industry-ready hardware, software, and organizational kit. All of these are based on artificial intelligence, as said, and the idea was to prepare the data, develop a specific model for this company, packaging the model, validate the model, deploy it, and then use this model. The pilots we have in Kit for SME are 4 pilots belonging to 4 different sectors: injection molding sector, quality system one, precision and tools, and electrical equipment. We had different problems and different kind of solution, but all these solutions were guaranteed thanks to the usage of artificial intelligence and to the usage to reference to the Kit for SME marketplace. So this was a brief introduction about Kit for SME project, and next we will see which kind of standards are used inside Kit for SME project, both from technical provider and both also from the pilots directly. Now I will leave the floor to Marco from C4Con. Is going to give us an introduction of the project. So please, Marco.
Thank you, Serena. C4Con is an open call that was funded by the KICLOS European project, and it is about promoting circular economy principles in the construction industry. It started back in January 2023, and it is now at the very final stage. It is ending in this month, and it involves 3 partners and 1 subcontractor. Next slide, please. Thank you. Okay, these are the 4 partners that are involved in the project. They are all located in Italy, and it is important to mention that the possibility of having Holonix as an ICT company, but also Focchi at the same time as an end user, an expert of smart facades, the designer and the producer, was a key element to perform the developments with a strong focus on the construction sector from the beginning, and to follow a user-centric approach that really allowed us to define requirements, keeping into account all the users that may interact with the platform that we developed in the future, as well as all their needs. And so the starting point of the project was the fact that building envelope product manufacturers consume a huge amount of energy and materials to produce their system, and these systems are often poorly reused and recycled. And this is because the construction sector still lacks a comprehensive life cycle perspective when they implement building components and systems. And this results in a resource and energy loss in the end-of-life scenarios. So we believe that reducing waste and promoting circularities can bring significant benefits to the developing economies in construction and lead to a boost of their competitiveness towards emerging markets. So the idea of the project was to develop an integrated platform-based digital tool that could improve and integrate circular economy principle at various stages of the life cycle to decrease waste production and promote circularity. And in particular, in the early phase of the cycle, we focused on improving the design of these systems and components. And in particular, we targeted the selection of building materials, aiming to make modular and easily disassembled components, where manufacturers can prioritize separating materials, reducing their complexity, and minimizing the energy used during the manufacturing phase. And at the same time, we also targeted factors that involve the moment when these components and materials reach their end-of-life stage. So, for example, an accurate and selective disassembly operation to prepare these materials for utilizing them and recycling them, and to enhance traceability and quality assessment. This diagram briefly describes the final solution, which is made of a range of services that are all integrated with a common backend. We developed three services, and these services were integrated with the Kyklos components, so the components of the main project. And in particular, we have a designer tool that is conceived for a detailed design phase in the early stages of the cycle. And thanks to this tool, the designers can identify all the suppliers for each building envelope component with the lowest environmental impact and with better circularity characteristics. All these options from the different suppliers are available in the cloud platform, so in the second service, together with the environmental and circularity data, as well as data about their life cycle. This is the core element because it allows multiple users, such as designers, managers, and people from quality department, to manage and obtain all the pertinent information. Finally, we developed an augmented reality snag list and dismantling tool, which from one side helps during the snag list of the facade to take note of all the damages, catalog them, and so that they can remain available also for the dismantling. And then there is the dismantling functionalities that allows to easily retrieve real-time information on the availability and the recyclability of the building materials in the facade. And this solution is also integrated, as I said, with all the services, with three services of the Kyklos environment, which are the PLM, for data exchange and storage, the lifecycle assessment tool that is the key to assessing the environmental impact of the different design choices during the design phase. This allows to have a wide range of indicators that include not only the global warming potential, but also energy consumption, waste generation, and so on. And finally, we have the blockchain module that was only examined as a possibility to store this design immutably. The cloud, since the project is now ending, we managed to validate our solution thanks to the end user. We managed to test the solution on 2 prefabricated modules for curtain walls. We added 38 circular entities, so 38 materials to the platform. And these were represented as circular entities with attributes, and the attributes are all the technical data that I mentioned. And we performed the design comparing all the possible options that were in the platform for the two selected modules, as well as snag listing and dismantling thanks to the dismantling tool Rialto. So this was a little overview of the project.
Thanks, Marco. It was very clear. And now we can leave the stage to Veronica, that will give us an introduction about the XMANAI project.
Good morning, everyone. I'm Veronica Antonello. Thank you, Serena, for the introduction. I work at TXT, which is the coordinator of the XMANAI project that was funded by the European Commission within the topic ICT 38, Artificial Intelligence for Manufacturing, and it is in the form of a research and innovation action. It started on November 2020, and it will end next year on April. So we're at the final stages for the project, for the execution of the activities and tasks as planned by the description of action, while, as we will see later, for the activities related to the standardization, we are still in the preliminary phases because, according to the Gantt, what we planned was to, first of all, enforce the main goals and activities of the project in order to have a clear overview of the development of the standard that we are going to analyze in the last month of the project. As you can see, it's a quite interesting project because it's about 6 billion budget, and it involves partners coming from different countries of Europe. Mainly, we will have the IT providers that come from Italy, Germany, and Greece, while the 3 demonstration cases are located in Spain, and in Italy. If we can go to the next slide, we will see what is the objective of XMANAI, that if we look at the ultimate goal, is the one to support the manufacturing sector in the transformation from a black box model to a glass box, where the transparency of the AI system are enforced. This is in order to put at the center of the human-machine interaction the people. The reason why is that we want to improve trustworthiness and transparency in the decisions that are made by the AI system. This is made thanks to the identification of a catalog of hybrid and graph-based models that are based on explainability, which is a concept that is developing more and more in the last years, based on the glass box approach that enables the user to understand what is the machine decision-making process. The idea is that what we want to create is a platform that responds to the question how a system works and how we can decrease the distance between the AI system logic and the human reasoning. For this reason, the aim is to design, develop, and deploy an innovative, explainable AI platform that is powered by AI models based on trust, human recognition, and with the final goal of improving the support in the manufacturer value chains. This is made by selecting baseline AI models that can be reusable to address any manufacturing problem, and also to train this model in order to have as a core principle, the demonstrator targets successful performance. For this reason, we created a platform that is the basis for the development of 4 manufacturing apps that are dedicated each one of them for the specific use case. For this reason, what we will have is a model that can be then replicated on a larger scale, because the use cases that we have is true that are related to the manufacturing sector, but with different use cases, meaning that we have different chance to exploit the XMANAI platform in different contexts. If we can go to the next slide, what we will see is the summary of these three main objectives. So as I was saying, we will have the identification and the training of the explainable AI models that will be then used to perform life cycle assessment management through the use of different pipelines that are integrated in the platform. And this will enhance the collaboration between the different actors involved in the data analysis process, meaning that we will have obviously the business expert that needs to understand the outcomes coming from the data analysis. We will have the data engineer that we will use in collaboration with the data science, the platform, according to the business objectives. If we can go to the third slide, we can see the architecture of the project from a high-level perspective. So as we're saying, we will have at the center the XI platform based on the approach of the explainable AI that is composed of different elements. We have the models, the model collection services, the pipeline execution, the secure asset services. So as you can see, we have inside this platform different kinds of components of assets that are integrated in order to perform the pipeline execution. This one will be then exploited by the single manufacturing apps that are dedicated, where they were created for each of the 4 use cases. And for that, we have not only a technical support dedicated to the development of the platform, but also we have a more methodological approach that is dedicated to the identification of what are the key features needed to create the system as explainable. And for that, we did a long interview with the final users, the operators in the plant, in order to understand is the best way to make AI system comprehensible for the final user. If we go to the next slide, what we see is that we will have we already have the first iteration of the application in the 4 different use cases, and now we are on the second iteration. So we validated the 4 manufacturing apps in 4 different plants of major player in the field. So as you can see, we have 3 big companies with different business sector, and then 1 SME that is Unimetric with a very specific use case based on methodology. This was a very useful, let's say, use of the platform, because we were able to validate the application with different objective and with different with different goals in mind. For example, we have the AI that is created for production optimization. Then we have the planning of the product demand. We also have the optimization of process and product quality. And then finally, that is the last, it's the more sectorial one, is the planning for a semi-autonomous measurement products. So as you can see, it's true that we have some points in common, but then we have some peculiarities that are specific for each use cases. And that's the work that we did with the specific manufacturing app within the more broad activities related to the development of the XMANAI platform.
Thanks, Veronica. Very, very clear also your project. Now we are going in the second part of the podcast. So in the first one, we see the project we are talking about. And now per each project, we give a very high overview of the standards that are adopted by the partner and the main pro and cons that the partner found. I'm going to start with the Kit for SME project. What we did was to make a survey inside the consortium, asking to all the partners, so from the technical one to also the pilots, which kind of standard they are using daily in their activities. So here we can see a list of the main standards that are used, and also the standardization committee in which the partners are involved. Mainly the technical one belong to a specific standard committee, while the pilots, for example, are not belonging to a specific standardization organization. And this is the overview of the partner and of the committee in which they are in. The goals in standardization in our project was to make the work related to the data model public and have the model accepted as a smart model, because in our project, we developed a marketplace based on a specific data model, and this data model was accepted as a smart one by the Fireware community. So in our project, we were able to create something that from now on could be seen as a standard. That is our data model. Then we tried always about standardization to participate in standardization bodies, promoting our data model and improving it also based on feedbacks and change and knowledge of people that are in these standardization bodies. And we achieved this joining the HS Booster service. We received like a consulting from HS Booster expert. And at the end, we decided to organize a podcast like this one in order to discuss with the partner about standardization, and also in order to know how the other European projects are facing with this topic that sometimes is not well seen from pilots, for example, because the technical partners are deeply involved in technical activities, and so they recognize the pro to have using standards, while sometimes pilots say that they are doing things in a specific way since their company was born, so they do not see why they should change or improve. Now I will leave the stage to Marco to see the same about C4Con.
Thank you very much, Serena. Starting from the solution that C4Con provides, as I said previously, the solution is made of a list of services that aim to promote circularity and to provide easy connections and collaboration among various construction and circular economy stakeholders. So, starting from a technical perspective, considering the architecture that I showed previously, the solution was developed following many international standards, as well as these international standards also involve the integration between all and the communication mechanisms between all the components. So the components are integrated for using REST API interfaces, which is a well-known standard, and also there were several standards in the LCA and the PLM components from Kiklos that involve the data representation and the data exchange mainly. And also the Android application Rialto was developed following material design libraries and guidelines. Thank you. But apart from the technical standards that I just mentioned, it is worth analyzing the value of the platform for the standardization in the sector as an integrated solution, so from a broader perspective. So the C4Con aims to be, as I said, a centralized solution that needs to collect technical data on various materials and products on the market with two main goals. First, to enable stakeholders to make informed decisions about raw material substitutions, and also to make available information and data that are functional for decision making during the entire process life cycle. There was the need to define a model that includes all the information that can be useful throughout the whole life cycle. So how data, what type of data to collect, how to store them, and what type of technical information to include. And this was to define a list of circular entities, so a list of materials that can evolve over time, and their attributes that are mainly the technical data that compose this material. And for this we started, and mainly the end user involved in the project started with the analysis of the prefabricated modules for curtain walls life cycle that were the final product in which the project was focused. And so the first step consisted of identifying, selecting and categorizing all the data that met the requirement for circular and ecological construction components, and how to organize them in a standardized system for the adaptation to our use case. And although there is a lack of specific policies regarding construction composition, we mainly focused on the performance indicator through the LCA, the presence of product circularity documents, and also we focused on facade-related data, such as administrative documents, such as, for example, manual for assembly and maintenance, drawing of technical systems, and so on, and performance statistics, as well as product certification. So we believe that all this information could improve the circular design. And so the project allowed to propose a method, a systematic approach to define, process, and store all the information that can be useful for the circularity of the product. And this approach, we identified some pros and cons on this approach that we followed, and in particular, what we think could be the biggest potential of the solution lies in the possible contribution to the integration of and adoption of standardized digital product passports and digital building logbook frameworks. Data regarding products and end-of-life disposition can contribute to standardized digital product passports, which can speed up future disassembly processes and reverse logistics. And also the establishment of digital building logbooks offer comprehensive and accessible repositories of building information, and these have already been identified as key enablers for sustainability in the future. Apart from this pro, there are other advantages that are about the solution itself. For example, the reuse platform, so the database that we collected within C4Con provides a comprehensive and centralized repository to collect the technical data on various materials and products on the market, and this can enable stakeholders to make informed decisions about raw material substitutions and allow for a seamless data sharing among all the users. Also, the platform helps so a centralized platform like the one we developed can help overcome the barrier of limited digital services for creating new value chains and organizing information on raw materials. As I anticipated, the design phase is the phase, we believe that it is the phase in life cycle of building components where it is possible to make maybe the most important decisions to reduce the environmental impact. And also, so we tried to have an intuitive web interface to guide the user to promote the solution for all kinds of users during the design. And also the platform allows for optimized communication and matchmaking between manufacturer companies and suppliers, and this can reduce the setup time needed for the supply chain organization. And finally, we identified two main advantages that come from having a dismantling tool that can allow to collect comprehensive material and component information for monitoring, reporting, and efficiently have the efficient dismantling operation. And in this way, the C4Con enables a real-time data update system for tracking all the circular initiatives. And this allows stakeholders to input and access data as long as changing occurs, so making documentation faster to make and faster to retrieve, and tracking all the recycling and the reuse of the materials. And also the project aims to reduce the dismantling time, and Rialto so the dismantling tool can play a crucial role in achieving this goal. The main issues that we faced we think can be also ideas for future development is mainly came from the need of, or at least the attempt that we made to integrate economic evaluation as a functionality of the platform. So to allow for direct economic evaluations and comparisons between all the products that are available on the market. This was a little bit of a problem because component costs can vary and are dependent on a high number of factors. So we think that further development and accurate economic data from suppliers can be necessary to allow for quick cost analysis considerations for all the potential materials and components. But we believe that as this component evolve and more suppliers join these platforms, the potential for achieving economic benefits through enhanced cost comparisons can become more and more viable. And finally, what we think has to be kept in mind using a sort of centralized platform is that the sustainability standards and all the best practices in the sector evolve very quickly over time. So we think that C4Con should commit to keeping all the standards up to date with the latest developments in the sustainability assessment methodologies.
Thanks, Marco.
Thank you. Thank you.
Now let's see about XMANAI.
Yes, as anticipated before, as for the XMANAI project, the standardization activities are still at a preliminary phase. This means that if we look at the figure that I put in this slide, that is the roadmap of the standardization task, we see that we are still in the first step of the gap analysis. This is due to the fact, as was saying, that we wanted to be sure what was the final version of the platform in order to be able to identify and select the standards that were more relevant for the project. So for now, we have performed a state-of-the-art analysis of the different standards that are currently ongoing, not only at European level, but also at global one. And in fact, we selected the most applicable documents. And in here, you will find only the one at the European level, since for the global one, they are the list is much longer. So for the scope of this presentation, I reported in here only the main one that are based on the artificial intelligence and as planned by the SEN. While for the global level, we also search for the technical committee and subcommittee and working groups, related working groups that are based on the artificial intelligence for the smart manufacturing. So as you can see in here, I just summarized the main ones, but we have identified a long table of the standards that are currently used. For now, we haven't applied any standards yet. So the next step will be the one to starting from the table that we created with the identification of the standards. The next step will be to create a priority of the ones that apply better to our project. And then what we would want to do was obviously to ensure a collaboration with other European technical committees to enforce the policy task. The final goal is the one to create some pre-standard that can be then used in the future also by other projects in the field of AI in manufacturing, but mainly in explainable AI. In fact, one of the challenges that we have is the fact that we are addressing not only AI, but mainly explainable AI. And since the explainability in the technological system is a branch that is quite new, the difficulty in order to find some standards that can apply to our case, it's bigger than by looking only at AI standards for AI manufacturing. So this is the work that we will have to do in the next month, and obviously any input and any lessons learned that we will have from this process, we will be very glad to share it in order to give and to gain more feedbacks. So for now, unfortunately, I'm not able to define what will be the pros and cons of the standards that we will use in our project, because the problem is that for now we only have created the state-of-art study that will lay the foundations for the next step of the selection of the standards that we will use.
Okay, thanks. It's interesting to see how a project is approaching the standardization task, because also in Kit for SME, Holonix had to do it since it was the first time we were leader of this kind of task. So we decided to start from a survey among the consortium, and then we understood that we had to try to open our horizon, joining like a Chess Booster or creating this podcast in order to exchange ideas with other projects. So it's interesting also to see how XMANAI project is approaching this topic. In general, so I remind that this podcast, as well as the first one and the next one we will have in October, will be shared on project channels and also on AI for manufacturing. And the next appointment will be with the final podcast of this series that is about standardization and data management. So we will try to involve projects that are facing the data management topic. I don't know if Veronica or Marco have questions or something to be deeply involved in this moment.
For my part, not, but that's a really interesting collaboration that we want to explore further on. So for the next meeting that we will have, we will be surely have more feedback to provide.
Okay, good, thanks. Marco?
No, also from my side, I have no other suggestions, and I also appreciate this initiative, and I think it can be very, very interesting to align and share ideas on this topic. But no other questions from me.
Okay. Thank you all for your support today, and you can promote what we did today also on your project channel. And thanks once again, and have a nice day.
Thank you very much.
Thank you.
Bye.
Bye.